Objective 3.7, to be able to write the equation of an inverse. The first thing we want to know is what type of function are we working with? So f of x here, we can see is a square root function. And to relate it back to our original square root function, the parent function, we know that it starts at the origin, and the square root of the input gives us the output. And the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So this is the original parent square root function. Now if we look at our equation, f of x equals the square root of a negative x minus 2, we want to see what transformations have been done. Well, we can see that we've got two horizontal transformations, and so to separate them, to see what we're doing, divide out the negative 1 from each term. So we've got the square root of a negative 1 times the quantity x plus 2. The negative 1 means it's been reflected over the y-axis and moved to the right 2 units. So if we think about what this looks like graphically, when you reflect it over the y-axis, the inputs change. So we have inputs now at 0, 0, negative 1, 1, negative 4, 2, and negative 9, 3. We also have to take those and move them to the left 2 units from where they are right now. So all these points in blue are going to get shifted to the left 2 units. And those are the ones in green. This is what makes up our equation for f of x. What we want to do is take our equation for f of x and find g of x, so that f of g of x equals x and g of f of x equals x. Well, we have to remember what that means for us is they're asking us to find the inverse. Well, in order to find the inverse, we've talked about this before looking at our original functions from a table and a graph and from the equations. In a table, we switch the inputs and the outputs. Graphically, that's like reflecting it over the line y equals x. And so algebraically, we follow the same suit. Before we find the inverse, though, we want to think about the original function here, that square root. And we want to think about the domain, how it's defined. And right now, it's defined with the domain from negative infinity up to including negative 2. So we have a restriction on that domain for f of x. So we have to think, since that's restricted, when we find its inverse, that should also have a restriction as well. So let's take a look at finding the inverse for this function. Again, we said we want to find the inverse for f. So we said when we're finding the equation of our inverse, we take our original function, and we talked about switching the inputs and the outputs. So your inputs, those are your x values, right? Your outputs are your y's. Same thing as f of x being an output as well. So if we switch the inputs and outputs, that brings us to here. Then we need to solve for the outputs because everything is defined as the outputs equals. So we have to undo our function to get y alone. Well, y is underneath a radical, and so in order to undo a square root, we have to square each side of the equation. So we have x squared equals, and when you square a square root, they undo, a negative y minus 2. Still trying to get y alone, so in order to do that, we have to undo the subtraction of 2 by adding 2 to each side. Closer to getting y alone, but not quite. Just as negative 1y. You are multiplying by negative 1. To undo that, you have to divide every single piece by negative 1. That will give us a negative x squared minus 2 equals y. The goal again was to get y, the output alone, which we did. So we found the inverse g, which is defined as the opposite of x squared minus 2. Now when we think about the inverse, right now it looks like our equation is a quadratic because it's a degree of 2. But we know, since we started off with the square root, it has to maintain its shape to be its inverse. So if we're reflecting it over the line y equals x, or thinking about switching the inputs and outputs in the table, it has to maintain this shape. So in order to do that, looking at it graphically by reflecting our given points here over that line y equals x, switching those input and output values, this is the graph that is being generated for the inverse. And we can see very clearly that this is not a graph of a quadratic. A quadratic is a U shape. That means you would have the other piece on this side, and we don't have that because of the square root. So to leave it like this would not be correct because there's a restriction as to what part we are using. So if we go to look at the domain for the function, we're only using this part when x is equal to or greater than 0. So we have to restrict the domain for this function to represent the inverse. So again, we're going to say the inverse exists when the domain is from 0, including 0, to positive infinity.